Hello everyone, my name is Rajneesh Khare and welcome back to the UiPath AI Center series. So far, we have explored several non-retrainable models such as sentiment analysis, object detection, and signature comparison. Today, we'll shift our focus to retrainable models in AI Center. Now, these retrainable models primarily follow the principles of supervised machine learning. So, in this video, we'll dive into the fundamentals of supervised machine learning. We'll explore what are its different types and also discuss its implementation methodology. So, let's get started. Let us begin talking about supervised learning in a way that is easy to understand. Think of it like this. Imagine a child who is trying to learn how to recognize different types of fruits. You show the child a bunch of fruit pictures and tell them the name of each fruit, like this is an apple, this is an orange, this is a banana, and so on. By seeing the pictures and hearing the names, the child learns to identify each fruit. Now, in the world of machine learning, supervised learning works in a similar way. We gave the computer a bunch of examples, just like the fruit pictures, and the correct answers, which in this case is the names of fruit. The computer studies these examples and learns to recognize patterns. Later, when we show it new pictures of fruits it hasn't seen before, it can make pretty good guesses about what they are based on what it has learned. So, supervised learning is all about teaching the computer using labeled examples. So, it can make predictions on new and unseen data. So, how does supervised machine learning work? Let's go through it step by step. First, we need labeled data. Now, what does it mean? It means that we need to have a data set where each piece of input data is paired with correct output label. Think of our fruit example. We have pictures of fruits, that is the input features, and their names, that is the output labels. The more labeled data we have, the better the algorithm can learn. Next, we train the algorithm. Now, this is where the magic happens. The algorithm looks at all the input-output pairs and starts to learn the relationship between them. It does this by adjusting its internal parameters to minimize the difference between its predictions and the actual labels. It's like the algorithm is studying really hard to get all the answers right. Now, once the model is trained, it's ready to make predictions. Now, when we give it new unseen input data, it uses the patterns it has learned during training and it predicts the output. So now if we show it a new fruit picture, it can tell us what fruit it thinks it is. Now let's talk about the two types of supervised learning, which are classification and regression. First, let's see what classification is. Now classification is all about predicting the category or class of a data point. It helps us answer the question, which category does this data belong to? So for example, let's say we want to identify patients with a specific disease based on their medical test results. Now, this is a basic classification problem. In this case, our data includes medical test results, that is our input, and the disease status, which is our output. The test results could be things like blood pressure, cholesterol levels, and other relevant medical indicators. The disease status is whether the patient has the disease or not. We use a classification algorithm to learn from this data. The algorithm studies the relationship between the medical test results and the disease status. It learns the patterns that indicate whether a patient has the disease or not. Once the model is trained, it can predict the disease status for new patients. When a new patient comes in with their medical test results, the model analyzes the data and predicts whether the patient has the disease or not. It's like having a smart doctor who can quickly assess test results and give you a diagnosis. Next, we'll look at regression and see how it differs from classification. Regression is about predicting a continuous numerical value, whereas classification was predicting about the category, or class of the data point. Regression helps us answer the question, what is the value of this data? Let's say we want to predict the price of a house based on its features. Now, this is a basic regression problem. In this case, our data includes house features like the size of the house, the location of the house, number of bedrooms, and so on. These features will be our input, and the sale price of the house will be our output. We use a regression algorithm to learn from this data. The algorithm studies the relationship between the house features and the sale prices. It learns how different features impact the price. Now, once the model is trained, it can predict the price of new houses. When we have a new house with its features listed, the model analyzes these features and predicts the sale price. It's like having an expert real estate agent who can estimate how much a house will sell for based on its characteristics. Now that we have understood what supervised learning is and seen its types also, let's talk about an important step in the process, that is data splitting. Now, in order to build a robust model, we need to divide our data set into two parts, training data and testing data. Now, why is this necessary? This is essential because it ensures that we can evaluate our model's performance on unseen data. Now, here is a visual representation of the data splitting process along with training and evaluation pipelines. Let's continue with our house price prediction example. We start with our entire dataset, which contains house features and the sale price. We split the dataset into two parts, 80% for training and the remaining 20% for testing. The training data shown here is used to train our model. This means the model learns the patterns and the relationships between the features and the house prices from this 80% of the whole data. Now the remaining 20% is our testing data. This part is kept aside and not shown to the model during the training phase. It's used to evaluate how well our model performs on new and unseen data. Once the model is trained on the training data, we have a complete model ready for prediction. But before we can trust it, we need to test its accuracy using the testing data. We test the model by using the testing data and then we determine the accuracy of the model. This step is crucial because it tells us how well our model can predict the price of a new house based on its features. And that's the data splitting process in supervised learning. By splitting our data into training and testing sets, we ensure that our model is robust and can perform well on new and unseen data. Now, there are other splitting ratios as well, which can also be used, like the 70 is to 30 ratio, where 70% is your training data and 30% is your testing data. But I personally find the 80-20 ratio to give the best results. Now, let's talk about some advantages of using supervised learning models. First, supervised learning models can make accurate predictions on new data based on learned patterns. For example, once our model is trained to predict house prices, it can accurately estimate the price of a house based on its features on which it was trained. Another major advantage is automation. Supervised learning can automate tasks and processes, reducing the need for human effort. Now, this is particularly useful in industries like healthcare, finance, manufacturing, where automated systems can handle large volumes of data efficiently and can also make smart decisions. Lastly, supervised learning models can provide valuable insights into data relationships and trends. By analyzing the patterns and relationships in the data, these models can help us understand the underlying factors that drive certain outcomes. So this brings me to the end of this video. We have covered a lot of ground today with respect to supervised machine learning. I hope you found this video informative. From the next videos, we'll start exploring the trainable models in AI Center and see them in action. So stay tuned for that. Thank you for watching.